So, draw angles. We're going to draw the angles with the given measure in standard position. So, standard position means drawn from the x-axis. So, like this angle here is drawn in standard position. Now, technically, these ones are as well for negative angles, but standard position always starts over here at 0. Okay, so number 6 is 110 degrees. So what quadrant is 110 going to end up in?
Oh, so two. Quadrant 1. 2.
2.
Quadrant 2.
Each quadrant only has 90 degrees.
Wait, so isn't it? Oh, is it not 2? Where
It
what
is
quadrant?
2.
Oh wait,
So
that's what I
it's
said.
1, 2,
one to the left
3,
here.
4.
So that is 2. Wait, did I say 1?
Yes.
Yes. That's why I said each quadrant only has 90 degrees. All right, so start here, and we come around, and then it's 20 degrees past, and I'm not looking for it to be perfect. I'm not getting out a protractor. That was geometry. I don't do that in here. If you drew it like, way over here or something, yeah, I'm going to mark it wrong. But I'm not going to get out and be like, I don't know, I think you went 22 degrees past it. Like, I'm not going to be that crazy about it, okay? This is geometry.
Do we use protractors?
I think we did for like 2 days.
Yeah,
No.
we
And I
don't.
think someone poked themselves with the pointy cord.
No. Like
That's a
we use-
compass.
Yeah,
Yeah.
you're right. I don't know that we
Compasses
use
are all
protractors.
circles, Charlotte.
I didn't use mine that much either when I was in geometry. They made this big deal about us needing one, and then I think I used it like 3 times. But I'm just saying, you don't need to go back and be like, oh my goodness, I need to get this out so I can get it exactly 110. I don't care. I just don't.
I don't even know how to use a protractor, so.
We use them with the compasses.
We used to have, I think it was Miss Marshall, she used to have this giant one. It was like this big to demonstrate with on the board.
That's massive.
It was pretty cool.
You know what else is massive?
Low tape.
All right. 450 degrees is the next one.
Quadrant 1.
No.
Yes.
Wait.
Wait, no, because 90.
360.
Yeah, it is. It's no, it's on the y-axis.
Yeah. Wait. 360.
I'm so smart. It's on the y-axis in the positive.
Okay, so 360 degrees is all the way around. Another 90 degrees puts me at 450 degrees, so I'm all the way around and back to the y-axis. So this angle is occurring here on the y-axis.
That is amazing.
That is fast.
Does it always start in the first quadrant?
Yes,
Okay.
because that's in standard position. And then if it was negative 450, let me just do this. Then we would have started down here and we would have looped around and it would have been down here
Whoa.
Because clockwise is.
Okay.
if it had been negative.
Just think if it's positive, you go up. If it's negative, you start down.
See, 10.
Bro, I can't see on my eye.
6 pi.
Oh, that's yucky.
No.
Oh.
It's 18.
It's just on the 0, it just starts in the same position that it would start in.
Yep, so we count around. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi.
That's a lot of squigglies.
So it ends up out here.
How did you do that?
1, 2,
What is pi again?
4.
3.14.
I know, but how did
159.
you go around counting the pi's?
Because
1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi.
So pi is just half.
Because all the way around is 2 pi.
Okay, all the way around.
Halfway around is pi.
Okay,
So we got
2
use
pi
1 pi,
equals
2 pies, 3 pies,
full circle.
4 pies, 5 pies, 6 pies.
Okay, so now I gotta redo that. So start right here. 1 pi, 2 pi, 3 pi,
2 pi.
4 pi, 2 pi, 5 pi, 6 pi.
All right, now normally I don't do odd problems. Okay, but I'm going to do this one because it's going to demonstrate something I briefly mentioned yesterday. 5 pi over 18.
Okay.
All right, so yesterday I pointed out the fact that if we had something like pi over 4, it breaks it up into the top part of it is broken up into 4 sections. Okay, if it was pi over 6, it's broken up into 6 sections. Pi over 2 is 2 sections. So what does pi over 18 mean?
It's a fraction.
The first quadrant, the first 2 are divided into 18, and it's the 5th one of the 18.
Yes. So basically, to give us a little visual here, or a large visual because I made that excessively large. This top part is divided into 18, meaning that this one is divided into 9 and this one's in 9.
Oh. Okay.
Okay? So I'm going to do this and I'm going to definitely do it wrong, or not separated enough. Okay, now, obviously it's not a really good, accurate representation because I don't have a protractor out and I'm to figure that out. But essentially, all we're doing is going around, basically it's a little over halfway. So 1, 2, 3, 4, 5, okay. There, and this right here is my angle. Now, is that exact? Definitely not. But it's close enough.
There are 9 of those blue lines.
There's 8 of them. It breaks into 9 sections.
Oh yeah, that's right.
So when you just do that red angle on number 11, why don't we do that on the other ones?
I did.
Fraction.
I just didn't draw it in a different color. I did because I divided this one into little sections.
Okay. So if
Yeah,
it's-
this one is, yeah, I did. It just, you can't tell because I did it in the same color I was already using.
But did we just ignore the 5? Where does the 5 come in? The 5 is
5
half.
pieces,
Okay.
yeah. So, like, if it was, like, 3 pi over 4, obviously that's something on our unit circle. But I would have gone, like, 1 pi, 2 pi, 3 pi. And that's how I would have gotten there. So,
Chewbacca.
let me see if you know this. How many degrees would that be?
About 50,
Why?
because, like,
Because we wanted
it's
it.
180 divided by 10. It's like 180 divided by 10 is 18. So it's like each one is 10 degrees. Each pi over
50
18
degrees.
is just 10 degrees.
Yep.
I knew that.
Each thing is 10 degrees. You don't need to know that. I just was seeing if y'all could figure out why it was. But yes, it is. If we divided 180 by 18, we would get 10. And so all of them are little increments of 10 degrees.
Wow.
All right. Next thing are coterminal angles.
Sounds like a disease.
No, it sounds like
Wow.
Shepard,
Oh.
I'm gonna quote that. You have the 100th quote, Shepard. How do you
Really?
feel? Yeah.
That's amazing.
I thought Ryan would get it for
How much space is left in your book?
sure. Like 500 pages.
Okay.
I think there's a bunch left.
All right. So coterminal angles we get by, it's an angle that's the same, but that's added or subtracted, like we've added or subtracted 360 degrees or 2 pi. Okay? So basically this is plus or minus 360 degrees or plus or minus 2 pi. And we can keep doing that over and over and over again. Okay? So in the pre-cal book, when they do coterminal angles, it'll give them a list of angles and say which ones are coterminal with each other. And so you just have to keep adding or subtracting increments of 360 or 2 pi to do that. Now, our book, though, says it wants one positive and one negative coterminal angle. Okay? So that means one answer is going to be positive and one is going to be negative. We may have to add or subtract multiple times to get there. Okay? So the first one, number 16, we've got 255 degrees. All right, so I take 255 and I add 360. And when I do that, I get
You get 500, 615.
615 degrees. Make sure you put the little degree symbol on there. So 615 degrees is my positive one. Now, couldn't I add 360 again and I have another positive one?
Yes.
Okay. So do you think that I want you to keep going and giving me one that's like 20,000?
Absolutely not.
No, I want the first positive and the first negative.
Okay.
Now, there's going to be one other problem that's going to be a slight exception, and I'm going to show you what I mean by that, but that'll happen in a second. Now, to do the negative one, I'm going to subtract 360. So 255 minus 360.
5, negative 5.
No.
Yes.
It's not negative
Negative
5.
105.
What do you
Negative
think?
105 degrees. All right, so there's my 2. There's my positive and my negative one.
I got one question wrong.
Now, on this next one, number 18, it is 820 degrees. So this is the one I said is kind of an exception. Obviously, I can add 360 degrees and I'm going to get another positive angle, correct?
Yes.
Can I also subtract 360 and still have a positive angle?
Yes.
Okay, so I would take either way on this one. Okay, you can add the 360, which is going to give you 1180, I think, or we can just start subtracting. I know that ultimately I need a negative one, so it would be a wise decision to start out subtracting because I'm going to have to do it multiple times. 820 is more than twice of 360. So I'm going to do 820 minus 360. And what do I get when I do that?
720. Oh, never mind.
460.
So 460 degrees. That's an option for a positive. I'm going to subtract 360 again because I'm still trying to get down to a negative. That's 100 degrees. That's another acceptable positive answer.
I don't like it
100 minus 360.
260. Negative 260.
Negative 260. There's my negative one. So any of these positive ones, and again, 820 plus 360 would have given me 1180. That also would have been sufficient. So any of these will work. Okay, and then we also have the negative one here. Okay, so all of these angles that are written are coterminal with each other. Now, degree ones, nice and easy. People don't usually have a problem with those. For some reason in radians, people get confused because it's fractions. So, 20. Negative 7 pi over 6. Now, we add or subtract 2 pi.
Add because it's negative.
No, she's asking.
No, I'm just making a statement. We will add or subtract 2 pi. But I don't have a common denominator there. I need a common denominator. Without having to think about it a lot, in terms of pi over 6, what is 2 pi?
12 pi over 6.
Yes. For some reason, people get stuck with that. Okay? 12 pi over 6 is 2 pi. So in this case, I'm adding or subtracting 12 pi over 6. It's probably the thing people mix up the most. They are like, I just can't figure out the common denominator. I'm like,
It's 6.
That's 4th grade.
The common denominator.
correct. That's why I get so thrown off. That's why I'm like, okay, we should know all of these things. Okay? If it was pi over 4, okay, and I wanted it in terms of 2 pi in terms of pi over 4, what would it be?
8 pi.
8 pi over 4. What if it was pi over 3 and I wanted it in terms of 2 pi?
6 over whatever the other thing.
6 pi over 3. Okay? So there's increments of all of that, and that's also why I counted things the way I did yesterday when I was counting, and I was like, all right, 11 pi over 6, 12 pi over 6, which reduces to 2 pi. That's why I was emphasizing that so much, because I knew this was coming. All right, so negative 7 pi over 6 plus 12 pi over 6 is what? 5 pi over 6, so there's a positive one. Now, obviously this was negative, but I still need one that's negative because I'm looking for the first negative one from that. So negative 7 pi over 6 minus 12 pi over 6 is negative 19 pi over 6. All right, let's see. 22. 20 pi over 3.
Ooh, that's a big one. No, it's 6 pi over 3.
Yep, plus or minus 6 pi over 3.
And now we can minus because it's a big one.
So I'm going to do it this way. 20 pi over 3 minus 6 pi over 3 is 14 pi over 3. I'm just going to keep subtracting off. I'll circle along the way. This one would work. Minus 6 pi over 3, 8 pi over 3. That one would also work. Minus 6 pi over 3. That's 2 pi over 3. That one would also work. Minus 6 pi over 3. Negative 4 pi over 3. And so there's my negative 1. All right, so any of those would work. And yes, we could have added 6 pi over 3 to 20 pi over 3 if you were just so inclined to want to add instead of subtract. But anytime that I see off the bat that something is bigger than 2 pi or 360 degrees, I start subtracting. Okay, and same thing if this was negative 20 pi over 3, I would have started adding until I got there. Okay, does that make sense?
Yeah.
Because otherwise you're doing more work, and not that this is hard, but it's just more work that you can save time on later.
So the original one we're given isn't a coterminal angle.
What do you mean? 20 pi over 3 is coterminal with all of these things I circled.
So what's the point? Like, not what the point, like, it's not, like, what are we trying to do? What's the purpose in finding the coterminals?
So usually it ends up being that we want to get to where we have something that's on the unit circle. So like 8 pi over 3 isn't on my unit circle directly. So, but 2 pi over 3 is. So there's going to be things that we do later where we're going to want to get it. So we may actually, within a trig function, take the angle out, find its coterminal angle, and plug that angle back in so we can use our units, like use our unit circle. But if you know how to count the unit circle, it's not that big of a deal. But if you had something way bigger, and like if I know this is way bigger, I could actually multiply 6 pi over 3 by 3 and then subtract that from that, and I'm going to get this. So like there's other ways to do it. It's something that we use inside of other things more later. They just teach it to you to make sure that you know what you're doing. All right. Next thing we're doing is conversions of degrees to radians and radians to degrees. So the conversion factor is 180 degrees over pi or pi over 180, depending on what we're solving for. So if I have something like 24, if it gives it to you in degrees, they want you to give it to in radians. If it gives you radians, they want degrees. So 24, 315 degrees is the angle that they give me, and they want me to convert it. So I do a little T-chart like you do in science. So I need degrees to cancel, meaning I need 180 on the bottom. Now, we do not type this in our calculator. Your answer will have a pi in it. We just reduce, okay? So I know that there's going to be a pi there. I need to reduce this stuff down. What can I take out of these things to reduce them?
180, I mean.
I can't take 180 out of 315. Okay, I can take a 5. What's going to happen when I do that?
You're gonna have to take.
Probably can take something bigger.
Take a 15 out of it.
I was going to say I would probably try 15.
Yeah.
I think there's
45.
I try 15, cause the 315 is turning into 31.
Now, let me back up. If you need your calculator to factor out things, that's fine. But I'm just saying don't type this whole thing in your calculator, because if you give me a decimal, I'm going to laugh.
3112.
Yeah, that's fine.
What?
3112. 31 degrees.
It's not degrees.
31.
Like 31 pi over 12?
Yeah, when we reduce, we take out a 15.
Yo, what is a T-chart? She just wrote.
315 divided by 15 is 21.
Oh, yeah.
180 divided by 15 is 12. I can still reduce that farther, taking out a 3, so I get 7 pi over 4.
7.
I think 45 will work.
Now, I'm going to also point something out to you. 315 degrees
Yes.
was on our unit circle.
That is crazy, but why? What does it
Oh,
do?
So if it's on our unit circle and we know that, do we have to do all the work, or can
You
we-
would still need to show that you're doing the
Okay.
conversion, but you could go straight to there.
7.
Normally, I'm not going to pick one that's on there on a quiz or a test, though.
So what is that one? Like the 7 pi over 4? Is that a
350.
cosine? Or is that a
That's an angle.
315 is the angle.
Cosine or x values,
So
sines or y values.
these thingies here
They're
are
angles.
just equal to the angle?
It's a different unit, but yes.
Okay.
All right, 26.
Oh, yeah, yeah.
500 degrees.
That's a big number.
All right, so this is not on our unit circle, at least not directly. So then pi over 180. Now, I'm going to make sure that we all know this little trick here. If I have something and I'm reducing and they have zeros at the end, I can take off a 0 from each one. So now I have 50 pi over 18. Can I take anything else out?
Yes.
2. 25.
A 2, which is going to give me 25 pi over 9. Is that reduced all the way?
No.
Yes.
Oh, three
Yes.
doesn't go to 25.
Yeah.
I'm too confident.
And that would be your answer there.
I've added.
No, you don't.
All right, now this next one. Notice also these were both positive. If these had been negative, my final answer would be negative. 28 is negative pi over 4. Now, people mix this up all the time, so watch closely. When I do my t-chart, negative pi goes on top, 4 goes on the bottom. Okay? This is like a fraction bar. The pi's on top, 4 is on the bottom. Now, I want to cancel. I need degrees. Okay, I need to cancel the radians. That means pi goes on the bottom, 180 goes on top.
Why did we do that again?
Because I need the pi's to cancel, and I want degrees, which means degrees needs to be on top.
Okay.
So pi's cancel, and then I'm looking for 4 into 180,
Reduce or multiply.
Oh, 2 over 9, 90
45.
over 2.
45.
So we were reducing.
Now, it was negative. Don't forget that. So this is negative 45 degrees.
So, negative pi over 4 is a radian.
Yes. Which again, this one would have been on our unit circle, so we wouldn't have necessarily had to do this, but
Okay.
4. Negative.
45 is pi over 4. That's awesome.
all right, 30. 14 pi over 15. So I'm just going to extend my little chart this time because I wrote it differently. So 14 pi on top, 15 on the bottom.
Pi's bottom.
Yep, pi goes on the bottom, so it's 180 over pi is the conversion. Pi's cancel. How many times does 15 go into 180? This is going to be a number you need to know. This is
30.
going to happen a lot. No.
21.
12.
I mean, can you
That's what I meant to say.
All right, so now 12 times 14.
144, 186.
Wait, what are we doing? 12 times 14?
Okay, so it's 12 times 44.
144 plus
156,
24 is.
168.
So this is 168 degrees. Whoa, that was a really big degree symbol.
Oh, I didn't know. It's okay, Zach.
All right, I'm going to stop there for today because there's a little bit more in this section, but you need to make sure that we can do this stuff, these conversions specifically, before we move into the last stuff in this section. So I'm going to go ahead and give you problems, but here's how this is going to work. I would recommend you start them because you're probably going to forget the stuff over the weekend. We're going to finish this section when we come in on Monday, and then you'll have the rest of the time to work. We have about 1, 2, 3, 4, About 5 more problems to do.
Okay.
Okay, and then all of the stuff will be turned in together on Tuesday. Okay, so it would be recommended you at least start this weekend. If you don't have to do it all, but I would at least start this weekend. But your problems to this point are, let's see, 7, 13, 15, 17, 19, 21, 25, 27, 29, and then you'll get the rest later. That's all to where we are right now. Okay, and you're going to notice that as we do trig, you probably will have more problems than we've been having, okay? But we typically will have more class time. You still have some time now. You could knock out at least a few of these. And we'll wrap up this section, and you'll have a few more problems added on Monday.